Greetings, welcome to day 72 of projectDIG. Hope you're having a good day. projectDIG is a 2D multiplayer automation survival sandbox game that I'm developing here on Twitch and uploading all the VODs to YouTube. So, we're working on Tilemaps, trying to get them rendering, which we were successful in yesterday. And now we're trying to optimize them because frame rate's not the best. So that's what we're going to be working on today. I can show off what we did yesterday. See here. I think actually this will be the fastest way. The frame rate's okay in release mode, but I mean, we need it to be faster than this. So yeah, this is what we have here. So it's like 100 FPS, but that's in that is in release mode, so we don't like that. Okay. So I talked extensively yesterday, right before I stopped the stream, about how we can try to optimize it. I'm going to do a quick recap of that, and then we can dive in. Before I talk about how we can optimize it, I should actually kind of touch on what we are doing right now so we actually know what we're moving from. So currently, we're going through all of the maps and we are just like calculating the tile position, and then we are getting the tile data and setting up this tile render data object based off of the tile. And then finally, after we get all that information, we pass in the render data to our render, which then puts it into a queue of tiles that need to be rendered. So the problem with this is that we are doing it for every single tile, every single frame. And that's a lot of work because, you know, I think right now we have like 200 by 200 tiles. So that's 40,000 tiles being rendered, or like this is calculating. That's a lot of tiles. And it's doing a few, like first it has to allocate this new render data, 40,000 of them every frame, and then it has to calculate this group ID, which isn't that bad. But then here's the worst part, is that it has to do a hash lookup for the group ID, and then it has to push back the tile onto this vector. And so it's having to do, like, that pushback is expensive as well. So there's a lot of things we can do to try to optimize this. I talked about it some up here. Like, what would be best is if we didn't have to, like, let's just assume that the tiles never change. Then that means that we could calculate all of the vertices up front. We'd have to store a bunch of this information, but we could calculate all the vertices and just have it ready to be submitted to our render system. Where instead of having to like recalculate all of that stuff, we just go to our like here, this is where we're actually calculating the vertices, the vertex buffer and the index buffer. If we already had those calculated, that would be amazing. The challenge with that is that we're going to support the screen scrolling, and it's going to be a large enough world that we wouldn't want to have all of this be calculated beforehand. Do you do some sort of culling? Not yet. That's planned. Right now, we're not doing that, but we're not really taking up that much more space on screen, so yeah. That is definitely one thing we will do, and I kind of talked about that yesterday. I don't know if I actually have any notes in here about that. But yeah, cull it based off of the screen space. Yes, that's something we'll do. Yeah, so we want to be able to cache this information, but it's very large. We need to know like where we are caching it. I mean like what the cache is referring to. And we also are going to be supporting the world to be changed, so you can like, you know, dig up blocks, destroy them, whatever, place new blocks down. So that means that the tile data can change, you know, at some frequency. And it might be possible for us to update that information directly in the vertex and index buffers, but maybe not. Well, we probably only really need to update the vertex buffers. Like, I think the index buffer is pretty much always going to be more or less the same. Yeah, I think so. I don't know, maybe there's some way we can optimize this where we're not having to do this. Like, this vertex buffer is literally the same thing every single time. Where it's like, given what this is 6, so the offsets are always the same, where it's like the first value is always going to be the vertex count, which we haven't set yet, so it's like 0, so it's 2, the next one is 1, and then 0, and then it'll be 3, 2, 0, and then we, you know, add 6, and so the next 6 would be 8, 7, 6, 9, 8, 6, and we just repeat, like add 6, and for each submission of these, it's always going to be the same. So there might be a way for us to like optimize this or like to generate it. Like, we don't really need to calculate it individually. What we might be able to do is just like create this huge index buffer or something and just reuse that over and over again, and maybe just like cut off like, hey, we only have 30 vertices, so that means that we only need 30 of these entries or something. I mean, it's in multiples of 4, the vertex count, so let's say 32, which means, so we would just take the vertex count divided by the multiple of the vertices, which is 4. So we say, oh, we have 8, and then that means that we just need 8 copies of this vertex, or sorry, index buffer, which would be 8 times 6. So we would need to have 48. And so we just get the first 48 values of this, and that's it. Like, that's something that we could quite possibly do. We wouldn't have to recalculate it every single time. And we also probably have like a limit on how many we can have. Yeah. I think there's a way that we can do this, have this be static. Like, so one thing I was kind of getting at is, since this is changing, what I'm thinking we can do is, and this is what I did for Korea, is have it be broken up into segments. And so a segment can be like 16 by 16 tiles, and then we move on to the next group or whatever. So we could have some limit on that. Like, I don't know if we... Sorry, I didn't explain that well. I'll get back to that. I'm trying to think about this index buffer stuff. If we had 16 by 16 and we're doing submissions for that, that'd be 256 total. That's before we multiply by the vertices. So that's, we need 256 times 6 for the index count. And that would be like the maximum we would ever need if we're submitting it per segment. We might want to group the segments up, but if we don't, we could just have that be like a set size for the index buffer. And then, which is, isn't that 1536? Yeah. So we can have, you know, this index buffer 1536 with the set size, and we could just reuse that every single time. And we could cut off some amount if we need to, like if there are empty tiles or whatever. Oh yeah, there's my note. Respect the viewport and only draw visible tiles. That's the calling. I did have a note. I just didn't see it. So yeah, coming back to the segments, trying to explain that a little bit better. So what I'm thinking is that we'll have the world broken up into segments. I kind of drew this little sketch here. So imagine that each block here is a segment, and we can have them, I think in this case, I'm going to have them draw horizontally. So the first one would be 0, then there's 1, 2, 3, 4, 5, and then you go down to the next row. And so this would be like 0, and then 6, and then this would be 12. So it's basically, to get the index, it would be the width, which is in this case 6 segments, times y plus the x offset, which is what we have done in the past, like right here. That's how we calculate the tiles themselves. And so now we can just, you know, kind of do the same thing, kind of like we broke the world up into tiles, which is like 16 by 16 pixels. Now we can break that up into 16 by 16 tiles, or like 256 pixels. I'm not sure. We're probably not going to keep these sizes. Like, I'm thinking that for projectDIG, we'll end up having tiles that are either 32 or 64 tiles large. I'm probably 32. So they're going to be larger. I don't know. Yeah, and we can also change the size of the segments. We'll just have like these segments. I mean, this stuff here, that's like super easy to calculate. So like if I ever change the tiles, like I want to change this to be 32, then suddenly now, oops, sorry. Oh, I have to update this segment. Yeah, that changes because the segment, yeah, if I wanted to make the segments be larger, I would need to do that. I guess another way we could do this is say it would be like 16 times the tile size or something. And then here we could do 16. That's if we wanted to always be based off of tiles. But yeah, anyways, that's how that could work. So we're breaking the world up into segments, and then we are calculating all of the draw information for each segment and caching that somewhere. And then if we ever change a segment or a tile within a segment, that means that we need to recalculate at least some of the data in the segment, if not all of it. So we can like invalidate it. And then we can have a much more like streamlined submission to the renderer here. So by caching it, that means that we won't have to recalculate like all of this data, and we will have to make these submissions or add tiles into we'll have a hash map. Actually, yeah, that's right. We will have a hash map. Because oh wait, that's right. I was talking about doing it this way. Right. Having a fixed size of segments that we can draw. So that way it's in this contiguous memory here, the segment data. Yeah, I like that. Yeah, that's actually pretty cool. Yeah, I like this. So we can do, yeah, so let's see here. What's the best way to do this? So let's say that we did have, I guess I kind of wrote out an example here. Let's say that we do have like some position. So this is a tile position, 8234. Then we calculate the segment ID based off of that by doing this stuff here. That gives us the segment ID, which we can use in the segment indices. So that's a hash map. And then that gives us an index, which we can use to look up the actual segment within the array. So this is if we need to access it based off of the segment ID. And then we get the segments. So yeah, how it works is that we have the segment index, which is segment ID to index. And then we have an array of segments, which this index is used to access the actual segment we have. So that way we're not allocating new segments. It's always a fixed size. We always have that around. And then we have this, if we ever like clear up a segment, it's not being used anymore. Or it's not really a segment, it's a segment data. So how you can think of it is like, you know, this might be segment 6, but so that's the segment ID is 6 here, but the actual like index might be 2. And so in this list, segment ID 6 is using segment number 2. And then let's say that you move away from it, so it's not being displayed anymore, and we want to clean that up or free it up. What we do is we remove it from the hash map. So 6 is removed, and we add number 2 to the free segments. And so then that way it knows, hey, now free segment is available, and we can you know, later pop that, reuse it for something else. Yeah. What we probably will do is have on the segment data maybe an ID. Something like that. And so we can store the ID that it's being used for. And then we could set it to 0 or -1 or something like that. You know, an invalid segment. And then what I'm thinking we can do, which is kind of cool, is, you know, going to more data oriented approaches. iterate over our segments instead of like culling them based off of this. So like calculate, and this is what I did for Korea, is calculate the viewport, iterate over the viewport segments, and get access to them. But instead, what we can do is iterate over all the segments and then do a check to see if it's currently on the viewport. It would be nice to be able to move that stuff around, and maybe we could do that. That is another option. And maybe what we could do is try both approaches and see which one's faster. So another solution, instead of doing this whole free segments deal, which may not be as good, another thing we could do, which would actually make this a little bit better, maybe, is we could move any unused, the free segment, to the end. So we would keep it densely packed, where we'd have a counter, which is exactly what we did for our component pool. So we'd have like a segments count, and if it has 8, then that means that we are using the first 8 values or segments within the segments array, and all of the following ones are free and available. And so if we decide we're going to push a new one onto the segments, use another segment, we just increment that that segment count and start using the last one, 9 or 8, whatever. And then if we want to free one up, for freeing up like number 2, then we just swap out or like override whatever was in the last index. So actually that makes it a little trickier, because then you have to go update the segment indices, which kind of sucks. So maybe that's a reason why we wouldn't want to do it that way. I don't know. It might not be so bad, because that's something that you're not doing that often. Like, it's something that we'll be freeing up segments or reusing segments maybe once every few frames, or no, not even that often, like once a few seconds. So it's okay. If you're standing still, then you're not going to be freeing up any segments. So you have to be moving around and be away from a segment for a long time. So yeah, we could do that. I don't know which one is better. I'm not sure. Probably have to look at the data usage to see. But yeah, we could iterate over them. Might be better to do it the other way, honestly, with the segment count. It would mean that we'd have to update this, but that wouldn't be so bad, because we would have the segment ID stored in the segment data. Yeah. I think that might be a better solution. I think so. Let's go for that approach to start with. So what we'd have instead of this is just a, whoops, I meant to delete it. Is have a, what, like a UN32T, maybe even a size T, segment count. That's how many segments are currently being used in segments. So instead of doing this, we would do stuff like segment count, increment it, and whatnot. So yeah, and then we could just like keep them densely packed in the array, because I think that's how we'll be like, yeah, I think that will just be better. We'll still skip it sometimes. If we really wanted to, we could probably even avoid that. Like, what we could do is have our segments array, whoops, could be something like visible or segments within viewport. So this is like how they would be grouped up within the array. they wouldn't be separate arrays, but they'd be grouped up like this. Maybe I should put like parentheses instead. So that's the segments within the viewport. This is segments used outside of viewport. And then lastly, we would have free segments. And you know what? This looks pretty much exactly like what we have over, whoops, in our active. Wait, I thought that was, oh, it's component active pool. Oh, that's what I'm doing wrong. Active component pool. Yeah, that's like exactly what we do with our active component pool. Oops, I meant to go to the HPP. So we have it grouped up where we have our active components up front, we have our inactive component after that, and then we have our free available components after the inactive component. So it's like exactly the same way. I could see that being worthwhile doing. So then what we would just have to do is, so we would have this other array, which would be like, or not array, value, which would be like maybe like visible count or visible segment count, which would just be where does this end? Hey Ocker, what's up? Welcome. Thanks for saying hi. So yeah, I think that sounds pretty cool. So the reason why this is nice is that it means we can quickly yeah, so I'm not positive that this is good. It might not be worthwhile doing this. It really depends on how often this is having to change, and like, are we still having to iterate over those anyways? I'm not sure it's worth doing this extra step. Maybe it is, maybe it's not. But the idea is that what would be, you know, really nice is, and I'll do it this other way so we can say let's do use segments, and we'll just cut out that middle part. So this is the simpler approach, which is bisecting it with the use segments and the free segments. And this is, I don't know, trisecting it, whatever that's called. The trisection. With the segments, so these are all used. So we would be bisecting the used segments. The reason why that could possibly be good is then when we're iterating over the tiles, or sorry, the segments, we would only be getting the data that we actually want to draw. And so we would get that data and be able to draw it very quickly. So that could be super nice. One possibility that we could always do is trying to, like, maybe we don't need to do this, but we could have something else where like these use segments that actually has like another thing that it's like pointing to or whatever that's like cheap for us to get access to. That just tells us if it's within the viewport or not. And then so we can kind of determine, hey, do we actually care about this or not without getting all of the segment data, which is going to be a lot. And so we'll have like a cache miss. And actually, I don't even know if that's going to be a problem because segment data is so large that maybe we are going to always have it. Like, we're always going to have to go fetch a large amount of data. I mean, yeah, I don't know. That's something I'm still trying to understand and figure out about data-oriented design. Like, how much data is it getting with this cache request? So yeah, it might be worth it. I think what we'll do is we'll start with the simpler approach and see how that is, and then maybe later we could implement the more like complicated approach, because yeah, it's already going to be complex enough. But anyways, yeah, we can iterate over the use segments, up to the segment count, and if we have them grouped up, then we do need to have it checked, like, hey, is this segment within the viewport? And if it is, or more, if it's not, then continue, go to the next segment. If it is, then we need to draw that data, recalculate it if it needs to be recalculated. I think typically we want to do lazy calculation. Yeah, where we kind of invalidate it and let the drawing determine when it needs to be updated, because like maybe we invalidate it, but it's actually not really being drawn, or it's not being drawn on screen. It's like off the viewport. We're not drawing it right now, but it is something that we were tracking earlier. So we only will actually update the segment when we're going to go draw it. That's what I did for Korea, and I think it worked pretty well. Yeah, we only want to do the amount of work that we need to do. We want to be lazy here because that's how we optimize things. Okay, so yeah, that's I think that sounds pretty good. So now we need to figure out what's going to be in the segment data and how do we actually go about like storing and using all that. So we have our map here. Right now it has the tiles. I think I'm gonna move that down. So what we actually need to have is a bunch of information here. We're going to need to have, yeah, so segment ID. So we need this stuff. I don't know where segment ID should be used. Right now I'm gonna put it right here, but we probably want to move it elsewhere. We'll put the segment data here. What I might actually call it is tile segment. I think I like that more. And then the segments max. Yeah, I'm not sure where we want to put all this. Segments max. So that's the maximum number of segments. I was thinking about making it be -1 and then having invalid segment ID being uint8 max. So that way that's a reserved segment. So we can always just check, hey, is this an invalid segment ID? If it is, or like set it. So like whenever we set this up, we can say, hey, this is a segment ID, which is equal to invalid segment ID. So it is invalid to start with. So then inside of, we actually need all three of those in here. So in our tile map, now we need to be tracking the segments, the segment count, and the segment indices. A lot of data. And this is called tile segment now. I wonder if I want to do this. Do it like this. It's a lot of potential data there. Segment count, segment max. Let's rearrange these. I think that's okay. So what's in our tile segment? That's the biggest question, is like, what's actually in here? We got that all figured out. I think I might make a note, so we don't need this stuff. We kind of moved this already. I'm gonna put this up here for now. Just so that way in the future I can think about that. Remember to think about it. Segment count, visible segment count. Yeah, that's something we'll deal with later. Yeah, that's fine to remove. This exact example is okay to keep for now. Okay, so did I commit this stuff yesterday? I did not. Dang. Okay, maybe I should do that. Cause, oh wait, maybe I did. IO stream. Game. I don't think I did. Prefab tile. Yeah. Let's go ahead and try commit what I did so far, and then we can work on the optimizations. Just in case I screw something up, we can always come back to it. Okay, so I think that's good. We do need to stage that line at least. Render system, tile render data. Yeah, we do need that for now. I don't think we want that. Oh wait, no, we need this. Okay, I think that's all good. We'll go ahead and commit that thing to event. Guess we need that as well. Okay. Work in progress, tile rendering. One second. Let me just make sure I need to be. I forgot to upload something earlier to Dropbox. Just double check in here. Okay, good. All right. So let's figure out what we're putting in our segments. So we can look at the career code and kind of see what we did there. I have a pretty good idea. I actually don't know how much this is going to help us, but we can still look. We have, let's see, segment. It's going to be way up over here. Segment. So yeah, we have the segment vertices. That's where things live. Segment tile vertices, which is a tile vertex map. Tile vertex map is a map of tile vertices, and a tile vertex is a rendered layer, priority, and the array. Okay. So the render layer. Tile render layer is background, midground, foreground. Right, that's right. I forgot I had done that. That was kind of nice. I probably should add that in for this game to just like, go with. So pretty much what I did is I made it so that you can have a tile layer that supports like when it's being rendered. That's something I should look at. So what I mean by that is there are some tiles or blocks that we want to be rendered in front of the player, and sometimes we want them to be rendered behind the player, and it does make things sometimes be a little weird. But I think it also helps make it look better. So like sometimes you want stuff to look like it's kind of in front of the player, whereas other times you want it to look like it's behind the player. But you still want it to be using up the same tile map, because having the tile map is expensive, and so if you split it up into lots of different layers, then you're going to have a lot of holes within the map, and then it's kind of expensive to actually, you're wasting a lot of space. So in order to avoid that, we just have this idea of like a different layer that the tile map can be rendered on. So like here, this is background, midground, foreground. So like background, I think, is behind the player. Midground is maybe, or it's like background is behind the player and items. Midground is like maybe in front of items but behind the player, and then foreground is in front of the player and items, or something along those lines. It definitely made the game look better whenever I added that in. And then we have a vertex array. So yeah, we're probably going to want something very similar to this. I don't know about the render component. That's probably not something that we're going to have. I wonder how we're using that. We're probably to get the texture. Yeah, we'll probably, instead of having that, have a texture. Right, okay, so yeah. How this is, so like I said, it's the segment tile vertices is segment ID to the tile, or to this map. And then the map is a UID or an ID to a list of tile vertices. So how that's actually like to think of is our world is broken up into the segment, 256 tiles or 16 by 16, and then we have within that segment the different groups of tiles. So we will have like dirt is in its own tile vertex, stone is in another tile vertex, and so this is really like the tile ID is the tile vertex map. It's like the tile ID, so it's segment ID to tile vertex map. Tile vertex map is a tile ID to the tile vertices. And so, and then like iron can have its own tile vertex as well. And so we want something very similar to this, except instead of having the think we want something similar to this. We can think about that. Yeah, I don't know if we really want a mapping. That might not be worth it. We might want this to just be like a vector instead of a tile vertex map, you know, tile vertices or whatever. We're going to be trying to condense our tiles down into like smaller textures, or not, the textures won't be smaller, but the smaller number of textures. So that way we can batch them more efficiently. Instead of having stone be rendered all by itself and dirt be rendered by itself, we could say, hey, these two are very common ones. Let's add them together and render the dirt and stone at the same time by having them be on the same texture. And so in Korea here we had it so that the render component had that texture information. So we're going to replace this and we'll have a texture handle or resource handle for the texture here. Tile render layer priority. Yeah, we'll want the priority, I believe. So I think that's how we basically want to do it. So this array was what we used for rendering stuff. We're using BGFX instead of SFML, so that means that we're going to obviously need to use some other like data structure, you know, way that we're allocating and storing the memory to push it to BGFX. And we're kind of looking at that yesterday, and I think really what we're going to be wanting to use is a dynamic vertex buffer. So there's transient vertex buffers and dynamic vertex buffers. The dynamic vertex buffer, and we got this linked up here. Where does he say that? Oh, here we go. Static should be things that never change. Dynamic should be things that change sometimes change, and transient should be things that change every frame. So that was part of our problem, is that we're using a transient vertex buffer for our tiles, which is like not really what's happening because they're not changing that often. They don't change every frame. They change maybe once every, you know, few hundred frames or something. So if you're at 60, yeah, like they're not changing often at all. It really depends. Like sometimes, you know, maybe you throw out a bomb or something and it explodes and it destroys like 20 tiles, but then there aren't other bombs going off. The tiles aren't being destroyed and placed back down all the time. So yeah, it really is only going to be changing probably once every 10, 20 seconds. So yeah, several hundred frames. So, and that's like often even. Oftentimes you're running around, you're not changing them at all. So we can use a dynamic vertex buffer because they're obviously changing sometimes. I suppose one thing you could do is to say it's static and then clear it out whenever it is being like whenever we're going to create a new one. Maybe that would be worth it. I don't know. We can look at that a little bit. maybe we could say, hey, this is static, it's not changing, and if we do want to change it, it means that we're just going to make a new one. Maybe that's what we end up doing. So yeah, we can look at those two. Definitely not transient, maybe dynamic, maybe static. And so I have multiple things open here. So yeah, we want to look at the dynamic vertex buffer and the static vertex buffer, or they just call it a vertex buffer. And we will probably be wanting to use one of those because that means that instead of like setting up a bunch of stuff and then we have to calculate the vertex buffer afterwards, what we could just do is set up the vertex buffer. Where is it at? Render system. Set it up and like what we're doing here, and then we can just say, hey, draw this vertex buffer. And it will be that fast. It will be so fast. Yeah, so I was saying yesterday, the worst case scenario is if you change a tile that's bordering other I guess you would only ever be able to change, yeah, if you change a tile that's bordering other segments, then you technically have to change those segments as well because we support like kind of wrapping or connecting the tiles together. And so I think the worst case scenario, you know, this is actually a square. So if you put it on the corner, then it would invalidate this tile or this segment. This is segment to like the right here and the segment above it. Technically, they don't interact with the tile to the corners. So that means that at most, if a tile ever changes a single tile, then that would invalidate 3 segments in total, which would be 256 tiles times 3. So what's that? 7. That's 764? No, 768, something like that. Yeah, that's right. 768 tiles, which is, it sucks, but that's not that big. Like the screen, I think it contains 8,000, yeah, it's 8,100 tiles if you have a, I mean, that's if we are doing 16 by 16 tiles. 1080p, it would have 8,100 tiles. So, and if you have to, like, worst case scenarios, invalidate only 10% of them for frame, that's not that bad. If we use a dynamic buffer and we're able to update the information, and so that's a big difference, I think, is if we're able to go in and say, oh, you know what, instead of invalidating those entire segments, what we can do is go in and say, well, actually, the only tiles that we need to update is right here, right here, right here, right here, and then also that one. So we only have to update 5. And that would actually mean that we'd always have to only update 5 anywhere we go. So if the tile over here changed, it's just that tile, and then the tiles directly neighboring it. And that's that would be very fast. Like, this is still the worst case scenario because then we have to go look up the tile within, you know, neighboring segments, which is, you know, a little bit overhead. We'd have to, like, I think what we'd have to do is probably like have some sort of like invalidation where we say, hey, here's the segment ID that's invalid and here's the tile that's invalid within that segment. And then whenever we're rendering, we would iterate over all of the invalid segments, or yeah, all of the invalid information, and like we could group them up by the segment ID, and then we would just say, hey, update this segment. So then we wouldn't have to put them in a hash map or anything. We would say, hey, update this this tile at this segment. You know, keep using the same segment until the segment ID changes, and then we get the new segment ID. And yeah, I think that might work. It would mean that we would have to like pick out the segment. Yeah, we'll have to do some thinking on that. I think maybe one of the challenges is that how do we know, you know, we're looking at this, we have the segment ID to tile vertex map or tile vertices, and then the tile vertices would have all of the tile data in there. So how do we actually know exactly which tile vertex has changed? That might be a little harder to do. We would probably have to know what it was beforehand, so like store that as well. So we'd say, hey, this is the segment it's in, this is the position, and this is what it was before, so that way we can look it up. So we would say, oh, this was a dirt, so, and it changed to iron for some reason, I don't know. So let's go look up that tile vertex inside of the, you know, go, we know what segments it is in. We know it's a dirt, so that means it's going to be in the dirt group of tile vertices, and then we can iterate over those tile vertices. I don't know how we would know exactly what position it's in. So that might be kind of hard to do. It might be that we would need to iterate through the entire vertex array, or iterate through it until we find that position. Yeah. So maybe what we would want to do is, yeah, I don't know. We want to try to keep the amount of like lookups we're having to do down. We'll see. This is definitely tricky, kind of hard. There's so much stuff here. Like I said yesterday, I think I counted that we have like 400 lines of code just for all of this rendering data. It's a lot. So yeah, let's look at the dynamic vertex buffer versus the static vertex buffer and see what we can possibly use there. So this is the BGFX stuff. So that's actually really nice, is that I guess here we can have, maybe that's what we would want to do is pass in the memory. So this creates a dynamic vertex buffer and initializes it. We get the handle, but also we have control over the memory, right? So this creates an empty dynamic vertex buffer. Let me look at this. Flags, no flags. Buffer will be read from compute shader, be written into compute shader. Allow resize. Buffer will resize on buffer update if a different amount of data is passed. If this flag is not specified and more data is passed on update, the buffer will be trimmed to fit the existing buffer size. Buffer is using 32-bit indices. This flag has effect on index only on index buffers. Let's see. Update the vertex buffer. So that passes in new memory. Create the index buffer. I'm looking for, maybe it was here. He was talking about the dynamic vertex buffers. He says this code is allocating, emptying an uninitialized memory VB data, then initializing dynamic vertex buffer with that data. You can imagine any call that takes this memory pointer to do immediately freeing of that memory. It's because once function that you use to pass memory to BGFX executes on other thread memory will be freed. It's because once function that you use to pass memory to BGFX executes on other thread memory will be freed. I see. So this like gives handle to it. Make ref with release is default behavior, is meaning it means you're managing memory outside of BGFX. Make ref just points to that memory and structure used to point. I'm just trying to understand this. It's passing it to BGFX and calling. And once you should not be changing memory range you pass to make ref. Allocating a frame memory with standard new delete operators is performance costly. Using dynamic buffer, you can manage memory outside and then update it. Here, make ref buffer you're managing. So that might be what I want to do. Something like this. File1, create this vertex data, that's our buffer, fill up the data. We say update the dynamic vertex buffer with this vertex buffer handle and say, hey, make this, make a reference to it here. So, okay. So this vertex data would have something like what this is right here, these vertices. Or this vertex buffer, I guess is more of what we would be using. So here we actually have a transient vertex buffer, but it's all it needs to really be is something that, you know, it needs to be this ms decal size, right? So if we go up here, look at this, we initialize that. So it just needs to be this size. So that's what it really needs to be storing. Excuse me. Is like our position color vertex. And so what we could do is have this vertex buffer, and we're going to just update it. I don't really understand why we need a handle. For that. I'm still figuring that out. The one thing that sucks about this, and I'm trying to figure out, is how can we batch this nicely? So really, this dynamic vertex buffer, we can be using it for like anything. Like we can be changing in every single frame. It's just that we need a different one for every single submission, right? Because whenever we submit a vertex buffer, regardless if it's static, dynamic, or transient, we can only make a submission for a frame using that specific vertex buffer once. And so let's say that we make a submission for all of the dirt and stone, and we use, dynamic vertex buffer 2. Then if we want to make another submission that has all of the iron and clay in it, then that needs to be using a different vertex buffer, because if we use the same vertex buffer 2, then it would overwrite, and stone and dirt wouldn't actually be rendered, because now we're using the previous vertex buffer for the iron and clay. And so what we need to do is say, okay, actually let's get a new vertex buffer 3, so we have stone and dirt on vertex buffer 2, and iron and clay on vertex buffer 3. But we could be like changing whatever that data is, every single frame. Like that kind of doesn't really matter. That's my understanding of it, which means that I'm trying to think how we could handle that nicely, where maybe what I can do is have man, this is so complicated. It's crazy. I was looking for, what is this? Oh yeah. I got that working. We can get rid of this now. So what we kind of want to do is, man, this is so complicated. We have our segments, which contains segments, or was it? Tile segment contains a list of. So I guess I should start up here. We have our tile map. Contains a map of tile basically a list of tile segments. It's a group of tile segments. And then a tile segment contains a list of, or more of a mapping of, I don't know if we need a map. We might just have it be a list of maybe tile vertices. Tile vertices, it contains vertex buffer data, or maybe just memory. Yeah, vertex buffer. What is it really? Let me pull out. So what it really is going to be something like this. Position, color, texture, vertex data. For each tile. So tile vertices is tiles grouped together by the, what is it, the texture by texture and shader information. So if they have the same texture and shader, then they can be batched together. And then we create this, array of texture vertex data that we're using for every single tile. And then what I'm thinking, so that's great. That's how it's all grouped together. But let's say we want to render it. When rendering, we iterate through each tile segment on the Tilemap, and cull tile or cull segments out of view. Each tile segment, we want to, what do we want to do? Each tile segment, we want to well, we need to update it. Maybe we'll kind of write that out separately. Tile segment, we want to that's the tricky part, is that I'm thinking what might be good is, what if we just have that's true. So what I was thinking we would like to do, if possible, is, and I'm not sure how we can do this, we want to group up the tile vertices that, for each segment, we want to group up the tile vertices, or more of, I guess, what we want to do is say, we want to group up the tile vertices for each tile segment, for all tile segments, such that doing a mem copy to some oh, that just makes a reference. Oh, I don't know if that's actually gonna work. Never mind. Forgot about that. I mean, it could, but we'd have to be allocating a lot of data. I don't know if that's actually worth it. Yeah, because we're just making a reference. What I was thinking of doing is having this like huge array of data that we can just append all of the segments to. So we're like, hey, here's all the dirt and stone from this segment. Put it onto this huge block of memory. And now let's go to this other segment and add in all of the stone and dirt vertices. And then get the other one and add in all the stone and dirt vertices. And do that for all of the segments that are visible. So then we just have one huge vertex buffer of all of the stone and dirt that we can pass, we can submit to the or to BGFX along with the texture data in the program, and then we do the next group we'd say, okay, now let's move on to the iron and the clay and go through all the segments and get all those. That doesn't quite work because we need to have this huge. We need to be like, yeah, we're only making a reference, and so for every single one of those submissions, we need to be making a new array, like allocating a huge new array or whatever, or we have to keep that around as well. And then we would also need to be creating a new dynamic vertex buffer for that submission. So every single submission needs to have its own vertex buffer. Maybe we can group them up. I honestly don't know if that would be better or not. Another thing we could do, which wouldn't require us to group them up, and so in some ways it would be a lot easier, is that we would still have them be grouped up, but we would make a submission for every single tile vertex or vertices, so every single group per segment. So we would have this dynamic vertex buffer, and I think at that point it might all like almost be static, huh? Maybe. So we'd have a so here we're saying that the tile vertices is the tiles grouped together by the texture and the shader information. So that means, yeah, every single tile vertices is going to have its own dynamic vertex buffer and its own set of memory. And so we would make that submission. So we wouldn't really need to be calling this because it's going to have the same data, which is why I was saying maybe we could just be doing a static one. So we could scroll up, and I think we can find somewhere in here. Here's the create vertex buffer. That's the vertex memory. Whoops. Didn't mean to do that. So it can't be updated. So I'm just wondering if we're ever able to change this memory after it's been passed into the vertex buffer. I'm guessing the answer is no. That like makes a copy of it or something. So we call destroy. So yeah, one possibility is that we could destroy that vertex buffer. If we wanted to make a new one, it would mean that we'd have to recalculate this, like the entire thing. Which might be a lot of work. But yeah, we would probably, if we were wanting to do it, so it's static, we'd have to destroy the previous one and then recalculate the entire vertex buffer for the new tile vertices. But maybe that's okay. Give me 1 second, guys. Okay. We want to group the tile vertices for all tile segments. Doing a mem copy. Yeah, I don't know if we'll be able to do that. Thinking here what we can do with this. So I think the question is, are we able to update the dynamic vertex buffer? Would that be worth it? Or would it be better to just have a static vertex buffer? Yeah, so I think we have 3 options here. To a huge chunk of memory to make a single submission. So yeah, we have 3 possibilities. This is one, which is use dynamic vertex buffer for each group and submit for each group. Let's call it a tile group. So a tile group is a tiles that share. Let's change this to just be like text. Do I syntax text? There we go. Tile group. Tiles that share share a texture and shader. So that's a tile group. Use dynamic vertex buffer for each tile group for all visible segments. Copied over into a huge chunk into a memory buffer. Needs to be preserved, or yeah, I don't know, that's fine. So the vertex buffer and the memory have to be, or have to live for, I think, at least that frame, or maybe it's 2 frames. It can't be changed. I'm not sure about that. I think he says in here, right? You can mention any call that takes it to do immediately freeing that memory. PB data. Yeah, you can pass in the reference with release function null. So you can have it just point to that memory. Without a release function. Right. I don't think that really answered my question. But anyways, so something like that. Here's another possibility, is that we use a dynamic vertex buffer. And so this kind of falls under 1. It's like this is something that we would do with it as well. For each tile group, for each segment, for each visible segment. Update, what is it? When updating the vertex, the buffer, I'll just call it the buffer. When updating the buffer, we need to we only the changed tile and neighboring tiles are neighboring tile vertices are updated. Let's change that. When a tile changes, only that tile and its neighbors vertices are updated in the buffer. I like that more. Okay, so there's that way, and then we use a static vertex buffer for each tile group. So this is the same for each tile group, for each visible segment. When a tile changes, the entire vertex buffer is recalculated. So really the question is, is this good? I don't know which one is best, but is this even possible without like a ton of overhead as well? This is by far the simplest way. This does mean that we might be making like 50 dynamic vertex, or sorry, static vertex buffers that we'd be using for the segments. Maybe that's fine. It's probably fine. Yeah, I'm sure that'd be fine. We technically would only have to... Yeah, actually, I don't know about that. I guess what we would have to do is change... If a tile change... If we did number 3, the minimum number of things that we'd have to change are... whatever that previous tile was, we'd have to update that tile vertex. Or that tile group. Yeah, so we'd have to update the tile group for the previous tile ID of the tile that changed, as well as the new tile group for that, or the new tile ID for that tile, or the tile group for the tile ID of that tile, and then the neighboring tiles, tile groups. So let's say it was like dirt and stone changed. If those are all the same tile group, and you know, like maybe we change, like this is all dirt, and then we change the middle one to be stone, then that means that we would say, okay, we need to update this dirt tile group as well as the stone tile group. Oh, hey, they're all in the same tile group, so we only have to update that one tile group. If we had it so it was like, you know, it's all dirt, or maybe it's dirt and stone, and then we change one of the tiles to be iron, suddenly now we have to look it up, and we're like, hey, we have this tile group, iron and clay, but we also have this other group, the dirt and stone. We need to update both of those because we don't know where it's at, or we're using a static vertex buffer. So we have to, what we would do is destroy the previous one that we're using, allocate a new one, and set it all up. If we are able to use a dynamic vertex buffer, that means we need to figure out like how can we actually know exactly what tiles we need to change, you know. So we have this dynamic vertex buffer, memory, there are specific tiles in there that have changed, but how do we like index or know that, you know, or vertices, I don't know, like 20 to 23, so 20, 21, 22, and 23 are all this specific tile that changed, and that's the thing that we need to update. How about for if that's a good question as well. What happens if it gets removed entirely? It's a good question. I mean, technically, we kind of don't want to be drawing that. Hey Theo, what's up? Yeah, let's think about that. How could we when a tile changes the entire vertex? Yeah, I mean this. I think like we could have a mapping or how would we do that? That's so tricky. So yeah, we're going to have this dynamic vertex buffer memory, and we're inserting all the different tiles, and so we might have, and within this segment, and so we might have like, you know, it's like empty, 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 stone, dirt, 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 stone, empty, 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 you know, etc. And then at some point we might say, oh, within this segment, you know, this specific tile changed. How are we going to update that? Like, how do we know what index that is within the dynamic vertex buffer? Man, my nose is like bothering me. Must be having allergies. That must be it. So, how do we find, like, this might be the 12th entry or it might be the 20th. We don't know. One thing we could always do is have a separate array or something like that if we really wanted to, which would contain like an array of tile vectors or something, which is the position. So we would know, like, we could iterate through that, say like, hey, this is the tile that changed, like, the index 20, so that means that this is like 20 times the number of vertices for each tile, which is 4, so it's the actual index is 80 plus up to 4, so 80, 81, 82, 83, or whatever, something like that. It does mean that we would have to keep around another array of vertices another array which contains the tile vertices. It would actually need to be a vertex because the number of tiles would be changing that are in it. So we'd have to have, I don't know, it might work. So that's, I think, the best way to go about doing that. It probably makes sense to have it be an array. Maybe it could make sense to actually have it be like a hash map of like the index, and we could even, since we know this is true, it's going to be offset, so it's only 256. So actually it could be a hash map, or we could like do it in a smart way where that's I guess it's not too bad because it's only for the segments. It would be like, actually it doesn't have to be a hash map. We could have, this is what we could do if we really wanted to do it this way. We could have inside of our segment a what would it be, like a tile vertex data or whatever, and so that could be a struct, and that would contain the, I don't even know if we would need, it could, maybe we wouldn't even need it to be a struct, maybe it could just be an index. Yeah, we could actually have, here's a possibility. What if we had an array, which would be the segment tile size, or how many tiles are within a segment, which is just like, I think it's tile segment, or segment tile times segment tile, which is basically 256. And then this would be, I think we could make it be uint, let's see here, what would we want? Maybe a uint 16. And so it could be pretty tightly packed. And this is like the tile lookup or whatever, vertex lookup. And so for what we could use for this is we would say, let's say that tile, inside of our tile segment, we can have change tiles. So like a vector of a tile vector. And so this is changed tiles or whatever. And so then we could do something along the lines of, for each auto tile vector, position out of our change tiles, we want to look up, whoops, just used to saving. We want to look up, so we get the ID, which would be the, again, we can flatten it down to be like position.x plus the position.y times 16, which I think is, if we're doing it like this, we could just shift it over 8 bits, right? Is it 8? That's not right. 16. No, that's not right. It should be 4. Whatever. Times 16. Same thing. What's a segment tile? That's the easy way to read this. And then we could say, okay, let's do our vertex lookup and pass in the ID, and that's the vertex index. So we'd say this is the index for that vertex, wherever it's living within our vertices. So we know the position. So what we can also do is look up that tile. So we'd say, hey, let's get the tile ID for this tile, or yeah, something along those lines. So we'd say, okay, let's from our tiles or whatever. So maybe we'd have to have the map.tiles. Maybe we'd pass in the list of tiles or something. I don't know. Some way we would need to be able to get access to the map tiles. Maybe it's outside of the, like, there's our loop or whatever. So we have our map tiles. And we can get it, you know, we basically get the position. We can look that up, whatever. This would need to be like we'd probably do something along the lines of like local position for this. Whoops, local. I don't know, maybe it would be converted into the local position. Maybe we'd say like this would be map position would be like the position plus the segment offset or something. So this is our map position. We get the tile. With the tile, we can get our group ID. We'll just call this a tile. We get the group ID, and that allows us to look up our, I'm saying M, but I don't know, that's probably not right. Maybe we need to say like segment.vertex lookup, and segment changed. Whatever. Segment dot offset. Let's assume that we have this is a tile segment. So we have the tile group ID. What I was going to say is we want our vertices tile group ID. So that does this lookup for us, or maybe what we want to do is iterate over those. I don't know. We need to find it somehow. For now, we'll just say that this is a hash map, but we need to look it up in some way. And then we know the index now. It's right there. So we can, and maybe it makes sense to move this stuff up. I don't know. It doesn't really matter. Then we have our index. So this is like vertices, tile vertices or whatever, and this is the data. This is the actual buffer. Maybe we'll call it buffer. So there's the vertices, and then we have our buffer, and we have the index, and this is exactly where that tile lives, so we can actually update it. I can see that working. So we would only have to store a little bit of data to do the vertex lookup, and anytime that the tile changes, like we move where it's living, we would need to update that, which means what we would, yeah, anytime that we add the tile. So this is updating where it lives within that vertex buffer. I guess typically we're not going to do stuff like that though, right? Like it's going to be changing. So that's true, is that this is not really the common scenario. Well, it could be. So this is if it's in the same tile group. But what if it has changed? And then we have to update both. I don't know if this is really necessary. I think we should probably go with this approach to start with, number 3, and just see how that goes, because this is going to get us like probably 95% of the way there and have it be much simpler. The nice thing about this is that this would avoid any spikes, really. I think so. I don't know. Maybe it wouldn't. I think this is the best approach. This is what I did for Korea. I think this is a good trade-off. I think so. So we use a static vertex buffer for each tile group for each visible segment. When a tile changes, the entire vertex buffer is recalculated. So then what that means, what we'll do for this, instead of doing all this complicated stuff, what we could do is, and if we decide that, hey, maybe we need to, then we can do this. There is a possibility for that. I think we're still going to be able to cut down dramatically on the number of submissions that we're making, so that's good. Yeah, kind of. I mean, we're actually going to be making more submissions, but we are going to not have to recalculate quite as much stuff. So yeah, anytime that a segment becomes invalid, we will need to recalculate that vertex buffer. Recalculate it and create a new vertex buffer handle. So we'll need to do something like what I was saying up here, where we say, let's create a new vertex buffer. You know, set up the memory, or I guess we pass in the memory. So we need to do something like what this guy's doing, where we create this memory and then we create the vertex buffer and it takes it over, I believe. Maybe we can find some examples. So we pass in that memory, you know, we set it all up, we pass in the memory to the vertex buffer, we relinquish control over that memory, so all we are holding is a vertex buffer handle, and then whenever we're like, hey, this is invalid, what we need to do is destroy that vertex buffer. So it's a static vertex buffer. Destroy it, and then say, hey, let's create a new one. And let's populate all of that data. So that sounds pretty simple. It also means that we, on our vertex, or on our, what is it called? The tile, what is this? Well, I was actually, let me look it up here. We have the tile vertices, they're all grouped together, the information. Well, all I think it would need to contain is our, let's see, tile vertices. So tile vertices is the struct. Let's just put it down here, struct tile vertices. What is that going to need to have? It's going to have like a texture or a resource handle, probably this. I guess we could, actually we could get the other stuff. We could say this is a texture handle. I think that's what we want to call it. Texture handle. So that's our texture. We need a program handle. Program handle. Texture program. Then we need a vertex buffer handle. Oops, got that all messed up. Let me see. Yeah, that's a vertex buffer handle. I think that's it? No. What else do we need? texture, program, vertex buffer, buffer handle, I don't know, whatever we want to call it. I guess maybe we want to call it that. We technically also need a index buffer handle, but I am thinking we might be able to reuse it or something. I don't know. It'd be nice to be able to do that. Maybe we could have a static index buffer. Sorry, static index buffer here as well. And then for Korea, we had the priority and the render layer. So we probably want that too. Priority. And the render, or maybe we just want to call it the layer. What is the layer? The layer is which layer it should actually be rendered on. Yeah, that makes sense. Yeah. Yeah, I think that works. Yeah, so that should work. This stuff is so complicated. I've been talking about it for like 2 hours now, and then I talked about it for like a good duration a while ago. Yeah, it's just there's a lot of things to consider. Yeah. Tile segment. Tile segment. What does the tile segment contain? I think we talked about that, but I kind of forgot. Tile segment contains a list of tile vertices, so I guess we need a list of tile vertices. Tile vertex vertices. This could actually be a tile render data if we wanted to. Tile vertex. Tile group data? I don't know. Something like that. I'm not sure what I want to call it. Yeah, that's one thing I'm kind of thinking about here. I'm definitely curious if batching them would be better. I'm not sure. One thing we could always do is technically not batch them, but try to render them consecutively, maybe. Maybe that would still help it. So they would have static vertex buffers. But what we could possibly do is, especially if we had lookups, maybe, is do something like, hey, go through all of the segments and find the, dirt and stone group for each segment and render that. And so that way the texture is already bound as well as the program, and we're not having to change that. And then do the next one. So then do something like, hey, for every for the next group, which is iron and clay, let's go through every single segment and render that group if it exists. Maybe so they're not technically being submitted submitted together, but they are submitted consecutively, which could maybe help with the rendering and optimize it some. That would mean that we would probably want to make this be something more like, instead of a vector of groups, maybe, because this would mean that we'd have to iterate over all of the groups, which might not be so bad, especially since we're only going to probably have like a few groups per tile segment. So this might actually be the best way, but you could also have like a hash map of tile vertices, or it'd be like the group ID to the tile vertices, but oops, I had that spelled wrong. But anyways, I think a vector is probably going to be better. Tile group data. I think I like that more, tile group. Maybe we'll just call it like a tile render group. I think I like that. Tile render group. And it's very obvious it's about rendering and that they're all grouped together. Groups. Do we need anything else within the segment? We have the ID, so that way we can always do a reverse lookup. I don't know if we need that for sure, but I think so. Maybe changed tiles. We might still want that. It might be that we could just do the changed on the tile map. Yeah, I'm not sure. One thing we need to do is, since this is just a vector, we would need to do a group ID. Group ID, or maybe we could just call it the ID. So that way we can easily look up like, hey, which group is this actually belonging to? Because we need some way to be able to say, hey, group 12 changed. Let's invalidate it. How do we know what is group 12 if it's a vector? If it's a hash map, then that's pretty easy to do a lookup. We'd have the groups. The other way, so either we store it as a value within the struct, or we have a hash map to do it, and then we iterate over it. Yeah, we have it stored in the struct, and we find it by iterating over the vector of tile groups, looking at the IDs, or we have a hash map and associate it that way. Looks like I'm losing some frames here or something. Not sure what's going on there. So additionally, I kind of already sketched out this stuff. We need all of this. I think that's all good. This is going to be a BGFX. 132 player. Yeah, that all looks fine. This could be a BGFX invalid handle. Valid handle. Yeah, we need to set that stuff. The group ID is based off of the texture in the program. So I guess technically, yeah, I think we'd probably just want to cache that so that way we don't have to recalculate it every time. That makes sense, right? I think that's all we need. This is so complicated. The layer. I don't think layers are. We go to render component or component. It's a uint 8. These are uint 16s. Uint 16. All of these are uint 16s. That's fine. Uint 32, uint 8. That's okay. The tile segment is just a list of groups. I feel like that's wrong though. I feel like I'm missing something. Maybe not. Okay. So where do we store the changed segment data or changed tiles? Or what do we need to do? We have to have somehow, we need to know if the tile or the segment needs to recalculate the group, right? Or do we just recalculate all of... I guess that's one possibility. That's true. I'm just thinking, how do we know that we need to recalculate the segment information? Whenever we have a change tile, one possibility is that we could just destroy the tile segment entirely. Well, like I was saying, we only have to update the groups that actually changed, right? So what we could do is yeah, the challenge is that if we delete the groups, how do we know that that group needs to be added back in though? Without going over all of the tiles. So I think that's why it's like easy to just delete the entire segment and say, hey, recalculate this entire segment, because we don't know what... I guess, oh, I take that back. What we could do is have, if we did do like the change tiles in here, like maybe just a vector of tile vectors. So these are the changed positions, kind of like what I was talking about here to some degree. But what we could do instead is, oh, and let's actually not put the m underscores for those. What we could do instead is iterate through all of those, get the tile from the tile map, and then we could calculate which groups have changed. Maybe we could even, instead of doing this, just do group IDs, right? We know which tile is what. We can get the group ID from the tile. So, like I was saying, for every single... So this could then be a uint 32. And so this is the changed groups. Maybe I'll put a comment here. Changed groups. Groups that have changed and need to be recalculated. So what groups actually need to change? If we go back to this little diagram here I was talking about, where let's say we change this specific tile, then it's that tile, the previous group for that tile, the new group for that tile, and then the neighboring tiles, since they have some sort of connection. And so at most we would, like, if all of these are in different groups, then obviously we'd have to recalculate a bunch of stuff. But you know, sometimes we might only have to change like one or two groups. Usually tiles are grouped together, which makes this even better, because it might be that we have like a bunch of stone here or dirt, and then over down here we might have adamantite or iron or whatever. And so I imagine most of the time we would only have to be updating, like on average, maybe two, probably like 1.2 or something like that, tile groups. Usually, like if the player's changing stuff, you're like destroying tiles or placing blocks down that is surrounded by a bunch of empty space, because you can't like super easily dig in the middle of blocks. And I might even make it so that in this game you can't do that. You only can place and access blocks that are exposed. Something that I have definitely considered. So then that would mean that at least one of the neighbors is empty. Is meaning that you would only ever have like up to 4 tiles that could have changed. And I guess technically 5, so at most you would ever have is 5 different groups that would change. So yeah, we would just say, hey, these are the groups that need to be updated based off of, you know, it'd be group for this tile, group for this tile, group for this tile previous and new, group for this tile. Put them all into here. Maybe what we would want to do is have this be a hash set instead. I don't know if we need to do that. I don't know if we need to do that. A hash set. One thing we could do is just sort it. That's something that I never really did for Korea that I'm like now I kind of realized I could do, and is oftentimes potentially much more efficient, is to just sort it and then say, hey, for every single, like, sort it, which I don't think is typically too bad. You know, it's not that expensive compared to like having to like manage it while you're inserting. And then if the value is the same as the previous value, just skip it. Keep going until you hit a new value. And that's essentially the same as having a set, you know, unique values. And so we would only have to, you know, we would update those groups. I think that would probably be okay. Yeah. So that's how we could track the groups. I think that works. The changed groups. So that way we don't have to recalculate all of the groups whenever a tile segment changes. So that's a good little optimization that's not too expensive. And so every single frame, like what we do is whenever we render a tile segment, we look, has any of the tile groups changed? Well, first we would probably say, hey, does this tile segment exist? If it doesn't, let's calculate all of the groups for it. So iterate over all the tiles within it, create the tile groups, and then I think that works. And then we will Yeah, and then like otherwise, if it already did exist, we can check to see if any groups changed. And if it did change, then we need to update those groups. How are we going to update the groups though? That's a good question. I mean, we have to iterate through all of the tiles, right? I guess what we would just be doing, iterating through all the tiles, checking to see if that tile changed. Or if that tile is part of the changed group. And then that tile is part of the changed group. It's kind of ugly, actually. Now that I think about it. Because that means that we have to be doing... we have to go through all the tiles for every single changed group. Look to see if it is part of the group. And then if it is, you know, add it to the vertex buffer. I don't know. I think right now, honestly, what might be best. Well, I was thinking of just like, let's forget that and do the tile segment thing. Because if we did that, well, how are we going to do the groups themselves? I guess what we could do, maybe we could do it that way, is go through all of the changed groups and delete the group corresponding to that changed group. And then after we've done that, we iterate through all of the tiles and oh wait, that doesn't work. I was gonna say if the group is missing, then we add it, but that only worked for the first one. I feel like we need a hash map. A forklift god. Do I know Java? No, not really. I do C++ mostly. Like I used Java in college, but that was long ago. So I think we'll end up needing a hash map for this. We could use it here, or at least whenever we're setting it up, we kind of need a hash map because what we're going to need to do is iterate through all of the tiles and push that tile into the group. So we need to do a group lookup for every single one. That sucks. So yeah, that would be the group ID. So I guess the good question is like, why would we? So we're going to be adding them in with a hash map. Yeah, it definitely sucks. I wish this wasn't the case. But I don't know how else we could do that because we have... I guess we could do it that way instead of having a hash map. We could have, I guess that's always a possibility, is a... No, that's still a hash map, right? No. We would have a vector of groups. And yeah, that's right. That's how you can always avoid a hash map. Do you ever use recursion in your games? Yeah, I've used it in some places. It's not used super commonly, but it does have its uses. There are times you want to do that. So, what was I thinking here? Yeah, instead of doing a hash map, what we could do is something like... kind of like this vertex lookup, actually. So we could have this be a uint32. This is the group. Oh, wait. Yeah, this is the group ID. So it would be storing a group ID, and we could look it up by the position. Kind of like what I did here. So we could have the group lookup. And so each tile would have its own group lookup, right? How is that useful, though? It would be, oh, sorry, this wouldn't be the group ID. This would be the index for the groups. So yeah, this could be, I mean, it could be a size T or it could be a uint 8, whatever. So this would be the group lookup. Yeah, right. So this is, maybe we could just say size T. So this is, lookup group index based on tile position. Does that actually help us here? How does that actually help us, though? So we have our change. I don't know if that is actually helping us. So I'm trying to keep this all in my head. It's starting to be a lot. Should have had 2 cups of coffee today. Groups that change and need to be recalculated. So what would that mean? That we could iterate over this group lookup. And so we would say, hey, let's find all of the indices that match this. We could actually, at that point, if we did do that, make this be more efficient. I guess that could kind of work. I mean, technically we could do this with the tiles because, yeah, I don't know how useful that is because we're already being able to look up the tile information. I don't think we need to do this, but what we could do is have a vector, right? I mean, or we could have a vector where we just wanted to push it back, or we could add them of all of the tiles that need to be changed. And so what we could do is iterate through all of the tiles. We would then what would it be? I guess we'd still be doing that, right? So okay, trying to figure this out. So this is a uint32. This is the group ID that changed. So we'd say, hey, for every single group that changed, so this is the group ID out of our groups, segment dot changed. we want to then iterate over all of the tiles. So for every tile in our tile map, well, it's really within the segment. Oh, that's kind of ugly. I guess what we'd have to do is say for X. Let's just do this in our segment.tiles. This isn't quite what we could do, but it would end up being kind of like this. It's a little bit more complicated, but anyways. So then we could have the group. I guess at that point, yeah, this is the same, huh? Needs to be recalculated. Hey, Cooler, what's up? Yeah, I don't think that this is actually really helping us here. So this would be a new tile render group, I guess at that point. We'd just say, okay, let's like, we first need to destroy the previous group, which would mean we would have to look it up. Let's just do group ID. Whoops, group ID. We need to destroy these handles, so we'd say like group is equal to that, and then this is a tile render group, and then we need to say like bgfx destroy both of these. Just do it like that. We destroy those. I guess we wouldn't have to create a new one, huh? Because we don't have to create a new one. We just have to invalidate those. Because everything else is staying the same. That's true. So we destroy those, and then what we need to do is create new ones. So we have to like allocate some new memory and then create new ones. This is so ugly. I was trying to see if I could come up with a way so that way we wouldn't have to iterate over all the groups. For every single group, we have to iterate over all the tiles. The other way we could do it, especially if we didn't do it this way, like let's say the first time let's forget about this whole like changed vector thing, and we're just wanting to populate our groups. What that needs to look like, it's kind of like this. But we need to say, hey, for every single tile within our segment tiles, which isn't quite what we're going to be able to do, but something. It's actually like, hey, at this tile position to this tile position, we need to calculate the actual tile ID. Get that tile ID from get the tile index within the map. And then in here, what we want to do is we need to get the tile group ID, and then we need to look up the tile render group for that. Something like this. I think we need to say, hey, if that doesn't exist, then we need to add it, right? So something like a find, you know, this is our group, auto, segment, groups, dot find, the group ID. You know, if it exists, if the group, then that means we need to actually, or I guess it really is that. If it doesn't exist, then we need to create a new one, right? Thinking about that. What is that? This is a group. Well, that's technically like a group editor. This is the group. If we can't find it, then we need to make a new one. Segment, render group. Yeah. Maybe we don't do it. Yeah, we have to set it up. This stuff. This is. Hey, Summit. How's it going? We need to create a new group. I guess we could do it like this. I mean, yeah. Do we actually want to do it like that? We do need to set it up. So we're gonna need to say, hey, the text is equal to this, the program is equal to this, etc. You know, set it up. And then we actually have the group itself. Otherwise, we just have the group editor, whatever. Finally got my triple project solution working. Engine test, and game. Nice. That's awesome. Hey, Froggy. What's up? So then we have the group. So either we need to get it and initialize the group, or sorry, create a new group, or we just get the group. If it doesn't already exist, and then we need to do something else. I'm wondering if this is actually good though. It might be better. So this is one possible solution. I'm gonna write another one. And so then we have our group here, and now we can actually add, you know, the vertex buffer. Or I guess we can't create the group until, yeah, that's true. We need to set it up. Well, by default, it will create it, right? I guess that's one thing we could do. Is instead of doing a find, I think we can just do... We'll find... Oh, that's if it's a hash map. That's right. So we need to set up the, like, the vertex memory, you know, add in... like, append the data, whatever. Same with the index memory, and then once we've done that, at that point, actually, oh, that's a good point. Is that we have that data? Yeah, you know, I think we don't want to do it this way exactly. We want to do it this other way, where what we'll do is we'll have... some temporary hash map, I'm thinking. So we have like a hash map of group ID to our so that's really a uint32 to the, what was it? The tile render group or something, right? Is that right? I guess what we could do instead of doing it to the group, maybe that would be better, is have it be a vector of tile vectors, or maybe it could be a vector of tiles like this. That's the tile position. I mean, technically, if it's within the segment, it could be a uint8. I don't know. It doesn't really matter that much. This is a temporary thing. So what we would do here is we would say, hey, let's calculate the group ID for the tile. Tile.group, whatever. Group. It'd actually be more like the texture shifted over by 16. Plus the tile program. Something like that. That's the group ID. And then we need to say, hey, let's just add this. You know, this would be like our groups, tile groups. I don't know, tile groups. We would add this like this. So it would just be like pushback. This tile. This tile position, right? Yeah, we don't want the actual tile. We want the tile position. The position is something like this, right? It'd be tile.x, tile.y, whatever, something like that. That's the position or the index. It's more of the index. Let's call it the tile index, which we might already have access to at this point. I don't know. We'll just, yeah, we'll do it like this, tile index. So we know exactly where it lives. So then what we can do is, so this will like group everything up, all of the tiles up by groups. So then we can iterate over the groups. And the nice thing about doing it that way is then we actually know that it doesn't exist. And this, yeah, this is so much better. Because now what we can do is say, hey, for every single, we can do some structured binding group ID. And this is tiles, right? This is the group of tiles. So we have the group ID, and this is out of our tile groups. We can then, saving, we can then say, okay, well, we know that this tile group doesn't exist, right? So we can just, we can create a new tile group. And then what we want to do is populate it. So we'll populate it just like what I was saying we would do over here. Which we could figure out, you know, maybe we just peek at the first tile or something to figure that information out. Because all of the tiles, we know that the tile is going to have the same texture and program. Like the group ID is based off of those. I guess it's true that they might be on different layers, which could be weird. Maybe we just never group the tiles together. If they're on a different layer, they would never be on the same texture. Maybe that's the best way to do that. Priority. I think that, I don't know about that one. The priority business. That's a little weird too. I am not sure about that one yet. Hey Sniper, can you explain how Tilemaps work and how would I want to draw in my map? That's what I'm trying to do right now, actually. It's really complicated if you're trying to make it be optimized. I mean, the simplest solution is, hey, iterate through every single tile on your map. So your tile map contains a list of tiles. Iterate through every single tile and draw that tile. What we're trying to do is optimize it because we have that working right now. If I think so, this was the debug version. I think I should be able to go to one of these. Did I update this recently? I think so. Nope, not recent enough. So here you can see I'm drawing all the tiles, but it's really slow. Like we're only drawing tiles and we're at 120 FPS. Whereas like before we were drawing the tiles, we were at like 800. I think honestly, and the tiles aren't changing, so we should honestly still be at like 700 FPS or more. The reason why this is so slow is because we're going through and redrawing all the tiles and we're calculating all of that stuff every single frame. To optimize it, which is what I'm talking about, is that you start caching that information. You're like, well, we already know that the tiles are not changing very often, so let's just store that information. But it still can, since it can change sometimes, that means that we need to like try to like split it up a little bit into chunks, or what I call segments, so that way if we do change something, we only have to invalidate a little bit of the data. Like, would I want to draw tiles if I'm not generating a different map every time someone makes a new game? I don't know anything about your game, so I can't really say for sure. You always want to be drawing the tiles. You only want to draw the tiles that the player can see, but if you can cache that information, then that's great. I don't know if your game supports like changing the tiles. If they can't ever change, then that means that you could cache like very large chunks. If you have smaller worlds, then you can actually store all of the vertices for everything, and potentially just figure out exactly what you need to be pushing. It is going to be like Stardew. Okay. So that means that you probably have larger maps. So you definitely want to, I would say, be caching it or something like that. So I don't want to go over all of the stuff I've been talking about, but if you watch the last few days, which isn't a ton, I guess it's a little bit, you'll kind of see how it's working, and also I'll be implementing this stuff, like the actual solutions with the segments and everything. So, and at some point I will do a recap video. This will probably go into next week's recap, where I go over all of how the Tilemap works. But yeah, it's quite involved, and honestly, I'm still trying to figure out the best way to do it, but that's the best way for this game, which will be a little bit different than Stardew, but it might not honestly be that different, because like, let's say that your plants are on the tile layer or on your tile map, then that means that you can technically change the tiles as well. Hey Hawker, take care. So anyways, what we want to do is like set this up, our tile group. So we can initialize it, and then what we can do is say, hey, for every single tile in our tiles, this would be like the tile position. We would then want to, I mean, technically this is more like tile positions, so let's do that. Say, or indices, I guess that's the index. So then here we would want to look up our tile. It would be something like our tile, our map tiles. Oops, tile is equal to that index, something along those lines. And then we would want to add that information. So actually at this point we'd probably want to, you know, like allocate memory. So we'd say, hey, let's you know, I think there's a alloc memory. So we'll just do like it's not the group. This would be like vertex memory is equal to this. And we're gonna do this something similar for the index memory. And then here we would, this is true, but what I'm confused is how to tell what tile it needs to draw and in what spot. So you do the viewport thing. So you know, your viewport, what you can see on screen, your camera, whatever. You look to see what tiles are actually on that viewport. You know, just by like calculating, you know, you're going to have a huge map of tiles, and so you just figure out like the offset where that tile is at. You know, you could do a 2D array, or you can have a 1D array that is like in rows or columns, whatever you want. And so you just figure out the correct indices, either with a 2D array, it could be X and Y values for the tiles, and you just figure out like, hey, is this tile actually on screen? If it is, then you want to draw it. And then you can do some optimizations, like let's say that you have multiple layers or multiple tile maps and they can be overlapping each other. If they completely obscure the underlying layers, then what you might want to do is just start at the top layer and work down. So you'd say, hey, the topmost layer, is this visible? If so, then we can cull all the rest of the layers underneath it. We don't need to worry about rendering it because this one is going to be obscuring the rest. If you do have like some transparency, like the tiles are not necessarily always blocking the tiles underneath it, then that means that you would want to start with the back layers and draw all of the backmost tile maps that are on the screen, and then you move up to the next layer and so on. Yeah, there's a lot of ways to go about doing the tile maps and drawing them. There's probably tutorials online. I don't remember. I did it for Korea like 7 years ago, whatever, and I like kind of figured out how to do it. And then I made a lot of optimizations over the years and kind of really figured out how to like push it to its limit. And I think I have a fairly good solution. There might be better ones out there, honestly. I'm not sure. But I think the general idea is that you need to be caching the information if you want it to be fast. So yeah, anyway, so we get the tile. And then what we need to do is actually like with that tile, we have the tile frame and the tile variant, or I guess we really just need the tile frame. And so we, you know, add to the memory, like basically push back the tile, you know, frame vertex, or what is it, texture rect or whatever. This is not really what it's going to look like, but kind of. So we would append data to this vertex memory. It probably wouldn't actually be pushing it back. We'd probably allocate it, and so it'd be more like, you know, I plus whatever, something. It'd be indexed. So we probably would need to iterate through this as like for int I equals 0, I is less than the tile vertices size, increment I, and then say that index is equal to tile indices I, and then something like this, kind of. So we'd go through and populate all of the tile or the vertex memory and index memory, and then at that point what we'd want to do is say, now let's actually set our vertex buffer handle to be our BGFX, you know, I think it's this get vertex buffer, and we'd pass in our memory, vertex memory, something along those lines. Then we need to do the same with the index buffer. And so that's how we could actually initialize. It would be all of that. I think that's how we could do our groups. So that means that we would be getting rid of so technically with this, we could do the same thing for our we could do something like this for the changed if we wanted to. Hey Loco, projectDIG is going pretty good. Thanks for asking. Yeah, it's good. We're just working away, trying to do Tilemap rendering right now, or optimizing it. I created like a super super lame solution for rendering our Tilemap, and it works, but it's slow. How are you doing? So yeah, for the changed, if we wanted to do changed, we wouldn't want to do it like this. That sucks. Group lookup. I don't think we want to do that stuff either. One thing I was thinking about doing is like this could stay the same. We would just have to populate the tile groups differently, right? So what we would want to do is you know, basically say if changed, then what? We would want to I think what we would want to do is something kind of like this, where what we would want to, before every single tile, no wait, no, first what we would want to do is we would say for the change groups, I mean this is a hash map, right? Yeah, so we could just add the change groups. So we'd say for group, in segment.changed. Say tile group. So this is a group ID. Tile groups. Group ID. Is this a new like vector, right? I think that makes sense. Is a new vector of UN32T, which is the tile indices. So we just set that up, and then what we could do is this exact same thing, but say, so we'll have a little conditional in here, which is we calculate the group ID, and then we say if the tile groups contains, or if we can find it, basically. If it contains that group ID, then we push that back. So we still iterate through all the tiles, and we're still doing this hash lookup, but it's faster than having to go recalculate all the groups, I believe. It should be. Being productive, nice. Good. Glad to hear productivity prevails. So I think this could work. I think it would be faster. Oh no, we could always test this to see if it's actually faster or not. I guess it's faster if we have multiple groups in our segment. I don't know. I think I'm not going to do this. So this is if we wanted to do multiple groups. I'm just gonna make a note. Let's avoid doing changed and see how the performance is. Yeah, just because this adds more complexity, and I could see it actually being slower, because that means that we're having to do this conditional lookup every single time, right? I guess it's not that bad. That's true. If we do a find, then it's not that bad, because it's actually exactly the same as this. We do a find, we look for it. If we can't find it, then we don't do a pushback. Actually, this is faster. Never mind. I take that back. The only time that this is pretty much equivalent, or yeah, this is faster. Okay, changed is faster. I take that back. Changed is faster. Because we're having to do that lookup anyways. We can do a find. Yeah. Yeah, I think that's okay. So it could be like this then. So it could be like, hey, if this is if we have changed. Wait. This is if it. I think what we might want to do is something more like this, where we say else if segment, basically if segment it doesn't exist. I don't know if it's empty. If the segment's empty, as meaning it hasn't been set up at all, then we need to just go through all of them. Otherwise, if we have any change stuff, then we want to do this. Otherwise, if it hasn't changed, then it's yeah, if it's not empty and it hasn't changed, then we just want to continue, right? I think that makes sense. And then Yeah, I think this works. So complicated. I think that all sounds good. So we have some, I mean, this is more than just like pseudocode. I think this should work. We just have to actually add it into the game now, into the engine. Yeah. I think I'm going to call it there for now. I have some other things I need to work on. So yeah, interesting stream. Thank you guys for joining. I appreciate it. Thank you to those that chatted. And I will be back tomorrow as always. We'll work on this. I might try to finish this up before we do a recap, and then we can do a recap video that includes the Tilemap stuff. That might be a good thing to do. So yeah, we'll have a recap video in a few days once I get this this done. Yeah, hopefully it'll happen soon. But yeah, thank you guys for joining. I appreciate it. I will be back tomorrow. I know I already said that. If you're not following, feel free to follow. If you're not subscribed to my YouTube channel, then you can subscribe to that as well. And I will see you guys tomorrow. Have a good one.